So, this is the first unit of Algebra 2, officially the first unit, which is about polynomials. So, this is where we will talk about these topics. Some of it you would be knowing it, you guys would be knowing about it, but we will just make sure that from a completeness point of view, we talk about all the concepts that is pertaining to this particular unit. So, we will talk about what is polynomial, we will try understanding that in detail, what do you mean by degree and terms. Then we will look at what do we mean by average rate of change of polynomials. Then we will look at how do we deal with addition, subtraction, multiplication, division of polynomials. So let's see how much we are going to cover in one class today, and the remaining things will continue in the subsequent classes. So for all of you, right, who are trying to understand how this whole course is structured, there are total 13 units as part of Algebra 2. So we are starting with the first unit. So we will not be able to cover one unit in one class unless we are just rushing through it. But then on average you can assume that 2 to 3 classes for covering one unit with enough practice. So that will mean close to 30-35 classes is what you would need to do one iteration of the entire syllabus. Alright? So we are talking about 36-37 classes. That translates into 9 to 9.5 months to cover everything. So before you guys start your next school year, we should be done with one iteration of Algebra 2. Is everybody ready to get started? Sanvita, Vasundhara, Arya? Abhi is not ready to start? Oh, that is scary. Siddharth, okay?
Yeah.
So there is one more child who is supposed to be in the class. She is going to be in person and she might be running a little late, but we'll see when she comes and when she joins. So again, as I had mentioned that in some of the previous classes, I have changed the alignment of the camera a little bit so that you guys get a better view of the video that I make. So the whole purpose of making the video is that you guys are able to watch it for revising what we learned. Now, first question to you all, what do we mean by polynomial? Very simple, lame definition that you guys can think of. When I say lame, I'm expecting you guys to explain that to somebody who is not as intelligent as you guys. Yes, Vishwa. Okay.
An equation or expression with like more than one term.
Okay. Yeah. Biswa, did you hear it? Did you guys hear what Siddharth said? Okay. Vasundhara, any point of view with respect to what is Yaryahi? Okay. So let me start from ground zero. And Sid, if you're feeling cold, you can come a little bit this side. I'm just waiting for the other child to come so that I can close the garage door. I think Sid's here. So, okay. So when we talk about polynomial, it's very important for us to first understand what is the basic difference between expression and equation. What do you mean by equation? What do you mean by expression? What's the difference?
Equation equals to something.
Yeah. So if I say x plus 2y equal to 15, and let me use the same thing, x plus 2y, and I stop here. There is a difference that you are seeing here right now. Okay. Here in this case you have an equal to sign. Here you have no equal to sign. When you have an equal to sign, what does it mean?
This is Sana.
Yeah. Yeah. So you can have a seat and see. So Sana, be little careful. Actually, we had a hail today morning.
Yeah.
And I had to rush everything, and so I'm not being able to clean it. So slowly, just watch your steps. Till you settle down here, I'll not be comfortable. Once you sit down, then get down. Okay. And if you want, you can sit down You can see what we do in the class.
Sure, yeah. I have a little one in the car.
Oh,
Travel with the car.
okay. So in that case, I will just close the garage doors, okay? So that
Sure.
mosquitoes, I can avoid the traffic.
Sure.
And after 1 hour, it will be done.
Yeah, sure.
Okay. Alright. So we have a new child in the class. And how does it feel when they call you a child? Everybody is like child for me, okay? That's how I treat you all, okay? I know you guys are high schoolers, but still, that's how it is, okay? So I have two daughters. My elder one is in college now, younger one is in middle school. So, Sana, a couple of things for you to be aware. Since this is your first class, you see an iPad there which is recording me, not you guys, okay? So whatever we do in the class, that gets recorded. I upload the video of the class for you guys only to watch and review. So what that means is you don't have to worry about taking notes. Everything is there for you.
Okay.
So then you can focus more on following the concepts, arguing with me, debating on it, practicing some problems that we'll try solving. Okay? And feel comfortable. This class is meant for making mistakes. More mistakes we make, more we learn. That's the deal. Okay? So that's a very boring speech that I start with whenever there is a new child in the class. Alright? So you sit down and we have some kids online. So today your timing is just right because we are starting the first unit of Algebra 2. This is the class for Algebra 2 in geometry, and so far we were just going through all the basics of algebra that we need to be aware of to be able to deal with Algebra 2 more effectively. So you have essentially have not missed anything. However, if you find something that is tricky, difficult, complicated, don't hesitate. Reach out to me saying, sir, can you help with this? Can you explain this? Okay, so don't worry about that. Always feel comfortable. You are under a parental care here in this class. Okay, that's how I would say. Now, so we are starting with the first unit, which is polynomials. And I was asking this question to everybody: what do you mean by polynomials? Sana, give it a try.
Polynomials, like multiple polynomials.
Okay. Yeah. So are you able to see the board okay, Beta?
Yeah.
Yeah. Okay. Maybe I will request you guys to get up slowly, carefully, and I'll move this. Can you sit? Can you move this one to that side a little bit? I want to make sure that everybody is able to see what is going on the board. Okay. So everybody moves a little bit this way so I can see you guys. Okay. And yeah. So polynomials. Sorry if we took 10 minutes to settle down. Right now we have two examples on the board. One is x plus 2y equal to 15. Second one is x plus 2y. The difference that we see between these two is this guy has an equal to sign, this guy doesn't. When you have an equal to sign, that means that there is an outcome. You add x and 2y and your outcome is 15. So when you have an outcome, no worries, beta. We just started with a bit of delay and you have not missed anything. So we're starting with the first unit of Algebra 2, that is polynomials. So I wrote these two here. Here you have x plus 2y equal to 15 and this is x plus 2y. The primary difference between these two is this guy has an equal to sign, this guy doesn't. When you have an equal to sign, that means you are saying that there is an outcome. This guy doesn't have an outcome. It's like my most favorite example that I give in the class. That if I am in the class, if I just keep smiling all through 1 hour, there is no outcome. There is nothing that you are learning. This is expression. You are just seeing my expression without any outcome. When you have an equal to sign, meaning I am teaching something, you guys are learning something out of it. So that's the primary difference between expression and equation. Okay? Beware, you will hear some dad jokes. Okay? So don't worry about it. It is just to make sure that all the kids are awake and with me. So when it comes to expression and equation, only difference is equation has an equal to sign. That means there is an outcome. Expression means there is nothing, there is no outcome, there is no equal to sign. That's the primary difference. Yeah? Everybody okay with that? Vasundhara, Viswa, Aryahi, Amrita. So you guys gave different definition of polynomials, and I have not touched upon that. I will start with expression and equation. Yeah? Baba, okay? Okay. Now, let's start our journey with polynomials. And I'll still not use the word polynomial. Let's look at it. 2x, 5x squared plus 3x, 6x cubed minus 2y plus 15x, 7x to the power 5 plus 6x4 minus 2x cubed plus 5x plus 17. What you see here are some examples of expression because none of them have equal to sign. Everybody agrees? Everybody can see what is there on the board? So all of them are expressions, no equal to sign, no outcome. But there's still a difference between the four things that we see on the board. What are those? The difference here is this guy. Somebody is saying something? I'm sorry, what?
I was going to explain, sir.
Okay. So let me complete that. I'll give you guys enough chance to deliberate this. Okay? And Sana, you can follow me, okay, right? I don't speak very fast. My accent is not hurting you. Okay, alright. No, because I'm not a native English speaker, okay, like you guys. So sometimes I doubt myself. So here, between this guy and this guy, what you see is, here you have just something written as expression, just one thing. I mean, though you have a variable and a number, but just one thing. Yes, Vaibhav?
I cannot hear you, sir.
I'm sorry?
I cannot hear you.
You cannot hear me?
Yes, sir.
Is everybody able to hear me otherwise? Aryahi, Abhi, Vishwa, Sundara?
So there's a little bit of a glare. How can you fix it?
That is the thing. This is not my laptop. Somebody broke my charger of the laptop, okay? So only for today.
Kind of got worse. It got really bad.
Really bad?
I can't see the whole board.
Wonderful. So that's a reminder for the kids to be in the classroom, whoever is living in DFW area. Is it slightly better?
Yeah.
Huh? Okay. So I will read those things, okay? And in the video you will find it much clearer, okay? So here I have just one thing, meaning which has a variable and a constant. Here I have two things separated by a plus sign. One is 5x squared, second one is 3x. Here I have three things separated by a one minus sign and one plus sign. So one thing is 6x cubed, second thing is 2y, third thing is 15x. That one thing that I'm saying, that thing is nothing but called a term. So everything that is separated by a plus or minus sign is called a term. So now let's talk in mathematical terms, unlike my lame way of looking at things, right? So here, this guy has only one term. This is an expression with only one term. This is an expression with two terms because these are separated plus. Here there are three things, that is three terms separated by plus and minus signs. So your plus and minus signs are the separators for counting the terms. Okay? So even if I have 5x cubed, y cubed, z to the power 18, this is still one term because there is no separator here. So regardless of number of variables, number of powers that you see, it is still one term because your separator is plus or minus sign. Okay? So here you have one term, here you have two terms, here you have three terms, here you have 1, 2, 3, 4, 5 terms. Now, when you have only one term in the expression, like you guys have heard the term monorail, rail that has only one track. Here it is mono. Mono stands for one. Monomial. When you have two, that is binomial. So this is monomial expression, this is binomial expression. Here you have three terms, trinomial expression. Here you have 5 terms, pentanomial expression. Now, I was trying to confuse you guys on purpose by giving all these cryptic names. Life is much simpler than this. So, if you have an expression with only one term, that is monomial. More than one are all called polynomial expressions. So, be it 2 terms, 3 terms, 5 terms, 20 terms, 75 terms, everything is polynomial. I mean, knowing binomial, trinomial is okay, but you don't really want to waste your energy memorizing these. If you have an expression with just one term, that is monomial. If you have more than one term, any expression with more than one term, that is polynomial expression. Is that clear to all of us? Sanvita, Ananya, Viswa, Sana, Siddharth, everybody okay? Alright. Bhav okay? So this is, now let's decode this a little bit more. So as long as monomial or polynomial expression is concerned, you guys would have a very clear picture of that whenever you hear the term one more time or ever. Yeah? That okay. Expression, monomial expression or polynomial expression, polynomial and expression. Expression meaning there is no equal to sign. Polynomial meaning multiple terms, monomial meaning just one term. Yeah? And something for Sana to know as a dad joke again. If I ask you guys who is the mother of math, I always say English. English is mother of math. Why? Because if you know the term and you know the meaning of it, half of the riddle is solved actually. So if I'm talking about polynomial expression, there are two things that I'm talking about. Polynomial and expression. And when you have to understand this, you will break this into two pieces. Polynomial meaning many terms, many, and expression means something that doesn't have an equal to sign. So an expression with multiple terms is what is polynomial expression. Yeah? Everybody okay? I know these are the things that you guys might be knowing already. I'm just re-emphasizing it so that it gets cemented in your brain and you have zero doubt when you have to talk about it or decode it. Yeah? Sanita okay? Ananya? Aryahi? Vasundhara? Everybody? Sana? Okay. So, Sana, you will feel like I'm putting you on the spot many times. That is because this is your first class, and whenever a child joins the first class, I'm always having a little bit of worry that, am I making sense? Am I able to explain things okay to you? They have been dealing with me or tolerating me for some time. This is your first class. That's what I'm asking, okay? Don't feel that I'm putting anybody on the spot, okay? You all are equally important for me. I'm just making sure that I'm keeping an eye on how everybody is able to do, okay? Now, so we looked at definition part of it. Now, let's go a little deeper inside it. Let's say if I am talking about 6x cubed minus 2x squared plus 15. Now we are trying to kind of process this, okay? What are we looking at right now on the board? 6x cubed minus 2x squared plus 15. What is that we are looking at right now?
Polynomial.
Okay. Biswa, what are we looking at right now?
Expression.
Expression, understood. What else? Sana.
A binomial.
Say that again.
Binomial.
Binomial. How about you, Sana? What do you think? It's okay, make mistakes, it's fine.
I don't know.
No, this is what we talked about, right? If we are looking at a polynomial expression, because it has more than one term. It's an expression because there is no equal to sign. So we are looking at a polynomial expression right now. And Biswa, you said binomial. If you want to be specific, you will not say binomial because binomial has two terms only. Here what you have is three terms. There are two separators. So you have one term here, another term here, another term here. You will not differentiate this guy from these two guys just because there is no variable here, okay? This guy is also a term. You are not going by what is the content, you are going by the separator. So this guy is separating these two. So you have two terms. And then this guy is separating these two. So you have total 1, 2 and 3 terms. Okay? Everybody okay with that? Now, so we have 3 terms here. But there's one more thing called degree. What do you mean by degree of a polynomial?
Exponent.
Exponent. Here if you look at it, what are the variables we have? We have only one variable, x. What is the power here? This is 3. What is the power here? That is 2. What is the maximum power? That is what is the degree of your polynomial. So in this case, your degree of, so this is a polynomial with 3 terms. If you want to be specific, you will say this is a trinomial. There are 3 terms here. And the degree of this polynomial is 3. You have maximum power of 3. So let me check if I'm at all making sense to you guys or not. If I'm talking about 16x to the power 8, what is the degree and name of this expression? Yes, this one.
Polynomial. Yeah, I would say
It's a monomial expression. Okay, yeah, go ahead.
I was also going to say the book.
Okay, so somebody is borrowing your idea. Sana, how about you, Peter? Monomial. Okay. What was the degree of this guy? 8. The only variable that we have here is x. The maximum power to that is 8. So this is a monomial expression with degree of 8. Is that okay? Okay. Now let's muddle the water a little bit more. 8x cube minus 15x to the power 8 in minus 16x to the power 15 plus 22. What are we seeing right now? What is the... Sanita got tired of me? Okay. So here we have 8x cube minus 15x to the power 8 minus 16x to the power 15 plus 22. What are we seeing right now? Ananya, what do you think, Peter? I will let everybody speak. So let's see what Ananya, Abhi and Vaibhav think. Aryahi and Vishwa, I'll give you guys a chance. I'm just trying to make sure that there is participation from everybody. So what is the, are we talking about a monomial or polynomial? Here.
polynomial, right?
Polynomial. Okay. And Abhi, what is the degree here?
15.
Yeah. Degree is 15. The maximum power to the variable is what will be your degree. Okay. Alright. So this was just like scratching the surface. Now let's go a little deeper into it. The next concept that we want to talk about is this. So now are you with me better so far?
Yeah.
Okay. So let's look at the next concept. Next concept is about average rate of change of polynomial. What do we mean by that? Average rate of change of polynomial. Let's say I have a polynomial which I'll give it a name as function of x equals x squared minus 2x. So I'm saying this is an expression, okay? I'm just assuming this, I'm just giving it a name, function of x. So I'm not converting this to an equation, okay? I'm saying function of x is a polynomial which is represented like this. We want to find out what is the average rate of change. What do we mean by that? Any thought?
Is it similar to like slope?
Is it similar to the slope?
Because it's like y2 minus y1 over x2 minus x1.
Okay. Have you heard about that before?
Yeah.
Average rate of change of polynomial. So average rate of change of polynomial it says here, when you're talking about expression, we don't have an equal to sign, but you have an expression which will give a name. Okay, let's say I will say this expression is equal to this function of, this polynomial is a function of x based on this rule. So when you're talking about average rate of change for this polynomial, what you're talking about is how is this changing? How, if you convert this into this form, if you read it like an equation, how every change of x is changing the overall behavior or the outcome of the expression. Okay, and that is what is called average rate of change. Let's say if I'm talking about x having a range from, let's say, 5 to 2. Okay, maximum value of x is 5, minimum value of x is 2. If I'm trying to find out the average rate of change of this polynomial, what I'm trying to find out is when value of x changes from 2 to 5, how much would be my overall value changing. So let's say when x is 2, what is the value of y? It is 2 squared minus 2 into 2. When x is 5, what is the value of my y, overall expression? This will be 5 squared minus 2 into 5. I'm just plugging in the value of x. What you see here is this became 4 minus 4, that is 0, and this became 5 squared, 25 minus 10, 15. So average rate of change of any polynomial says what is the final value changes, what is the change in y for every change of x. So y changed from 0 to 15, so 15 minus 0, this is a change in y. Change in x was from 2 to 5. So this was a change in x. This tells you 15 minus 0 is 15, by 5 minus 2 is 3, which is 5. This rate of change of polynomial actually signifies, are we talking about a positive rate of change? Are we talking about a negative rate of change? Meaning, for increase in x, is my outcome changing in a progressive way or is it diminishing? So in other terms, if you guys are familiar with the linear equation, change in y by change in x, it is nothing but rise over run. That's how you can relate to. So if your rate of change of the polynomial is positive, your rise over run is positive, you are talking about a positive slope. If your rate of change of polynomial is negative, that means your rise over run is negative, you are talking about a downward slope. Is it making sense to everybody or I'm just getting you guys confused? Abhi, Nanya, Haryani, Sanita, everybody okay? Alright, so rate of change of polynomial is nothing but how would your final outcome change for changing your input. Let's look at some examples. That would probably clear some dust for you guys. Let's look at one example or a couple of examples. I would want you guys to kind of scratch your head gently, because if you scratch it hard enough, then the outcome is my hairstyle. Okay? So Sana is getting scared in her first class itself. Okay? So s to the power h of t is a polynomial that is represented as 3 plus 3 squared plus 5. I'm just reading a question, okay? H of t is equal to t plus 3 squared plus 5. What is the average rate of change of h? Average rate of change of h over the interval t is less than equal to minus 1 and greater than equal to minus 5. Let me read the question for you guys one more time. This equation says h of t is a function of this. T plus 3 whole square plus 5. So the question is, what is the average rate of change of h? Average rate of change of h, which is a polynomial here, over the interval t being greater than equal to, t being less than equal to minus 1 and greater than equal to minus 5. Yes, Vishwa.
I can't read the top of the board. It's like, it's clear.
That's why I'm reading it for you guys loud and clear, okay? So what I'm saying is, you have, okay, let me write it at the bottom of the board, if that is the matter of concern. Okay, this is the polynomial given to us, where h of t is equal to t plus 3 whole square plus 5. We have been asked to find out the average rate of change of h for the interval of t less than equal to minus 1 and greater than equal to minus 5. Are you able to see it now, Vishwa?
Yes, sir.
Everybody on the screen? Okay. So, I want you guys to spend 5 minutes solving it. At least think about it and tell me what is your story. How are you doing it? Yep. It is greater than, less than equal to minus 1, greater than equal to minus 5. So how are you doing it?
I plugged in -5 first, and then I got 9. I plugged in -1 and got 9 again.
Okay.
It's 9 minus 9.
Yeah, it can be it's possible, right?
Oh, okay.
It is possible. Your slope is 0. That is the horizontal line. Yes, Abhi. So I have polynomial h of t, which is equal to t plus 3 whole square plus 5. We have to find out the rate of change of this polynomial for the interval t is less than equal to minus 1 and greater than equal to minus 5. Do you guys know how to do it? No? Okay, I'll come to it. So now how about you, Beta?
I got 0.
You got 0? Okay. So Sana seems to be comfortable with this one. That means she is inviting me to give her harder problems. Okay. So let's look at this one. Okay. Again, I'm not trying to make any personalized question set. But Vaibhav, how about you? Abhi wants me to explain this. How about you, Vaibhav? What is that you are coming down to? Are you able to solve it, or you guys would want me to give it a try? Yeah.
I got like an answer, but I have no idea.
What did you get? Tell me.
-5 is, I forgot what that symbol is called.
H of t. This is,
The greater than.
so see, this is how we read it. 5 is less than equal to t. T is less than equal to 1. So we read from left to right. Whichever comes.
Read it, can I just don't know how to say it because my throat is also.
That's okay. I will.
Can I type them in the chat?
Sure.
Okay.
How about Vasundhara, Vishwa, Rania, Sangeeta? What's going on?
I'm still thinking, sir.
Thinking? Okay. So, just because we started a little late today, I will try rushing through it a little bit, okay? So that we can deal with more problems. Because this is we are just touching the tip of the iceberg. We have a lot to do. Here, the question says h of t, it's a polynomial, which is equal to t plus 3 whole square plus 5, and we have to find out the rate of change of, rate of change of this polynomial over this interval, meaning initially the value of t was -5 and it increased to -1. Yeah. So when t was -5, how much is the value of h of t or y, whatever you call it? I put -5 here. So -5 plus 3 whole square plus 5. -5 plus 3 is 2, whole square is 2 square is 4. So this one is -2 whole square of that plus 5. So -2 whole square is 4 plus 5, that is 9. So when t is -5, we got the value of h of t. When t is -1, how much is the value? I'll put it here, -1. So -1 plus 3 whole square plus 5. Minus 1 plus 3 becomes 2 whole square plus 5. 2 square is 4 plus 5, that is 9. So how much my h of t changed? H of t changed from 9 to 9. So 9 minus 9, this is the change in h of t. For the change in t was minus 1 minus 5. Minus 5. So this was the final number and it came from here. So I'm subtracting it. So what we got is 9 minus 9 is 0 divided by minus 1 minus into minus plus 5. So 0 over 4, which is nothing but 0. Now rate of change of this polynomial is 0. What does it mean?
It's like flat.
Yeah. Abhi, did you understand what I did?
Yes, sir.
Okay. Now we have come to a point where by I'm sorry, Vika?
I have a question.
Yep, go ahead.
How you got 9 minus 9 and then minus 1?
So this is the range I had. This was the minimum value, this was the maximum value for t. Okay. So basically what it means is this is the range for which I have to check the rate of change. When t is minus 5, I plug it here in this equation. I got this equal to 9. Okay. When t is minus 1, I plugged in that value here. Again I got a 9. So my h of t changed from 9 to 9. So rate of change of any polynomial is rate of change of the polynomial divided by the rate of change of your input. dy by dx. Here st2 minus st1 divided by t2 minus t1. Yeah? Yeah? So basically when you come across this kind of situation, when you got your rate of change of the polynomial as 0, I am struggling with myself to figure out. I see a very nice drawing on the page, and this is something that I am very bad at. My drawing skills are horrible, which you will realize. But yeah, you guys are more exposed to art and craft. I was not. So, anyways, that was just a side talk. So here, when you see a slope of 0 or rate of change of the polynomial is 0, what does it mean to you, Sana?
Like how much it's changing over time.
Right. So it's saying 0. Rate of change of the polynomial is 0. That means my rise over run is 0. Meaning there is no rise. I'm talking about a horizontal line. So my rate of change of this one is horizontal. The slope of the line that it will draw is going to be horizontal. Does it make sense to everybody? If my rate of change of the polynomial is positive, I'm talking about a increasing slope. If my rate of change is negative, I'm talking about a downward slope. Yeah? Everybody okay? So now you're okay with it, right? I make some remarks, but that is just to encourage you guys for your talent, okay? Don't take it personally, okay? Alright, so we looked at what we mean by rate of change of polynomial. I will flash one more question on the screen. Ananya, are you okay with her? Ananya, Sanita, you guys have not spoken anything? Okay. If I flash another question on the screen, f of x is a polynomial which is equal to x cube minus 9x. It says, what is the average rate of change of f of x, what is the average rate of change of f over the interval 1, 6. So again, this is not different from what we had before, okay? So you can rewrite this like this. It's the same thing. You will have different representation of the same problem, but both mean the same thing. You have an expression given here, and you have been asked to find out the rate of change of x. Rate of change of f, the function for this range. You'll do the same way. I'm not asking you guys to do it because this is just extension of the same concept. As long as you guys are clear, I would dare to move on to the next topic. Is that okay? Vasundhara okay? Biswa okay? Abhi, Danya, everybody okay? Alright. So this is the second thing. So far, what we have covered is we talked about what is polynomial, what are different types of polynomials how do you describe a polynomial, how do you break it down, what do you mean by terms and degree of polynomial, and then we talked about what is the rate of change of polynomial. Now comes the actual thing that we want to deal with. All this is theory, okay? All these are concepts. Again, rate of change of polynomial is something that you'll come across for sure. And remember one thing, polynomial has no bias for the power. If you get to deal with a polynomial something like 2x minus 3 versus a polynomial like 16x to the power 19 minus 12, there is no difference here. You will treat them, both of them, the same way. Is that okay? So don't get overwhelmed by the power that you see. For us, this one is a polynomial with two terms, or a binomial, whatever you call it. This one is also a binomial with two terms, or polynomial, whatever you call it. This one has a degree of 1, this one has a degree of 19. But when it comes to treating both of them, we'll treat them the same way. Yeah? Everybody agrees to what I said? Okay. Now the next thing is addition, subtraction, multiplication, division of polynomials. This will be the most important and interesting part of our journey with polynomials. Okay. So let's start dealing with them. And this is where we will use a very simple concept called separation of concerns. Let's look at it. If I have x cubed plus 2x minus y as one polynomial, another polynomial is 2x plus 17, third polynomial is y cubed plus 2x squared minus 15x plus 18, other polynomial is xy squared plus y x squared plus 12x. Okay, I'm just picking it up. If somebody says add these four polynomials, what is that will go into your mind?
Combining like terms.
Combining like terms. That is the catch here. We have to be very, very stubborn about the fact that I will not try adding things which have no correlation. Okay? Which have no correlation. Let's say I have two pets at home. Okay? I don't have one, but let's say if I have two pets, two types of pets. Let's say if I have two dogs and one cat. Okay? At home. If somebody says, how many dogs you have? I will not say 3 dogs. Or I will not say 3 cats. Because cats and dogs are separate, belonging to separate category of animals. Okay? It will remain, if you have to add them, it will be 2 dogs and 1 cat. That's how it is. Here also, if you look at this one, x cubed and 2x are different creatures. Okay? I will not try adding these two. If I have to, let's say if I am trying to add this guy and this guy. Here I have x cubed, there is no x cubed. It will be just x cubed. Then I will add the like terms like what Sana said. So 2x plus 2x, 4x. Minus y, there is no corresponding y here. I'll just keep y as y. And then I have a constant 17. There is no constant here. Adding this and this polynomial would be pretty straightforward for me as long as I'm only trying to add or subtract or deal with the like terms only. Yeah. So, are you guys okay? Siddharth, okay? Okay. So now, if I ask you guys to add all these four, you will only look at, okay, I have x cubed. Is there any other x cubed here? No x cubed. Only one x cubed. This is xy square. This is y cube.
Okay.
Again, see, that is where I have bad eyesight. That's why I wear glasses. You guys are better off. Make sure that don't. Yes, Peter.
Can you if there was like an x to the power of 2, can you combine that with x to the power of 3, or is that not possible?
No,
Okay.
not at all. So that's what I'm saying. We need to be very stubborn about it. X to the power 3 and 3x, no correlation. X to the power 4x, no correlation. I can find something common between them, but when I'm trying to add them, I will not add them. There's one very normal mistake that we all do as a, due to oversight. Let's say if I'm trying to add these two, x squared plus 2x squared y plus 3xy squared plus y cubed. If you look at this one, this guy is actually these two guys are trying to mislead us. Here you have x squared y, meaning x to the power 2, and then a y. And here you have x, y squared, y to the power 2. You will not add them and say 5x squared y or 5xy squared. These two terms are totally different. They are not friends at all. They have no bias or affinity for each other. So they will stay isolated, not knowing each other. Okay? Is that okay? Confident okay? Or okay? Biswa, Vasundhara, Ananya, Sanvita, Sana, Abhi, Vaibhav, Siddharth. Are you guys okay?
Yeah.
Okay. Now, I will try to bother you guys a little bit. Okay. Let me see if I can. I have two polynomials. I'm trying to add them. X cubed plus 2x squared plus 3xy squared plus 5y squared. And now this is one polynomial. My second polynomial is xy squared plus x cubed y plus x cubed plus y to the power 3. These are the two polynomials which I am trying to add. And for all the kids on the screen, you guys will have the same concern. So I will use the bottom part of the screen. X cubed plus 2x squared plus 3xy squared plus 5y squared. So these are two polynomials that I am trying to add. Okay. Can you guys see the board okay? Ananya, Vasundhara, Vishwa, everybody can see the board okay? I'm reading it for you guys. Xy squared plus x cubed y plus x cubed plus y cubed is one polynomial, and there is a second polynomial x cubed plus 2x squared plus 3xy squared plus 5y squared. I want you guys to add them together and tell me what is the output. And honestly speaking, there is no big deal about it. I just want you guys to practice that caution that we made. Yep. Sanvita, okay, beta, you have not said anything today. I always see you participate.
Yeah.
How about Ariyahi is not well, I know. How about Vasundhara? You okay, beta? Vasundhara will give me a thumbs up, saying why this old man is bothering me. Let me solve this problem. I'll give you guys those 30 seconds or 1 minute to solve this. Yes, Babu, what did you get?
I got 2x cubed
Say it slowly for me.
2x cubed
Okay.
plus
Hmm.
2x squared
Okay.
plus 4x y squared.
4x y square. One term, right?
Yeah.
Okay. Then.
Plus
Mm-hmm.
5y squared
Okay.
plus
Mm-hmm.
x cubed y
Okay.
plus y cubed.
Okay. And for everybody else, remember one thing. One of my most hated statement. I always say, don't trust anybody, or I don't trust anybody when it comes to solving math. I'm not trying to be disrespectful to Vaibhav, but my message to you all is, find your own answer. Don't rely on anybody else. We'll see who gets it right. Yes, Samita.
I got 2x cubed
Okay.
plus x cubed times y
X cube times y. Okay.
plus 4x times y squared
Okay.
plus y cubed
Okay.
plus plus 2 times x squared
Okay.
plus 5 times y squared.
Okay. So basically, yeah.
The one with like the terms of 3, don't they go first in the equation?
It doesn't matter. Any sequence is okay. Yes,
Oh,
madam.
so we don't have to put it in like the regular order that we have to put in. It's just combining them.
Just combine them. Basically, you have to add them.
Okay.
Okay. So what Samita got and what Vaibhav got were the same. How about you, Siddharth?
Yeah, about the same.
You got the same. You guys are becoming good friends. Okay, we'll see. So 3 of the kids have got the same answer. I'm still saying to everybody else that don't trust anybody. Your friends will try influencing you. Find your own answer. Vasundhara, Viswa, Alyahi, Abhi, Ananya. Viswa is thinking. How about you, Uta? You got the same? Can you read for me?
2x to the power of 3,
Mhm.
2x to the power of 2, 4x y to the power of 2, y to the power of 3, 5y to the power of 2, x to the power of 3y.
Okay, wonderful. So you guys are all together so far. Let's see. Anybody got a different answer? No? So I will again, for all of you who are still working on it, let me just show you guys whether this answer is correct or not. Here, approach is very simple. As I said, we will just add the like terms. We'll start with the terms one by one. Xy square. Let's say I'm starting with this guy. Xy square. Do I have any xy square? No. Yes. So 1xy square, 3xy square gives me 4xy square. So I have just marked them. Okay. So this is done. Now x cube y. Do we have any x cube y? Only one. Only one. Then I have x cube y. This is also done. Then next time is x cube. Do I have any other x cube? I have one here and one here. So 1x cube plus one more x cube. 2x cube. Okay. Then we go to y cube. I have one y cube. Is there any other y cube? No, only one. So this becomes y cube. Mark this guy also. Then we come to x square. I have 2x square. They know the x square. So then I have 2x square. This is also done. Then I have 5y square. They know the y square. Anyways, we have marked all the numbers, all the terms that we have. So 5y square. So we got 4xy square, this is okay, matching. X cube y matching. 2x cube matching. 2x square matching. 5y square matching. Y cube and y cube matching. Now I trust you all. Okay. So again, look at this whole thing. This kind of problem, it comes to you in the exam, this is going to be a cakewalk. You don't really have to worry about it. You just have to carefully do it. How much time did I take? I just did not think too much about it. I just kept looking for matching terms. I picked up the first one, traveled the whole this thing and marked if there is anything matching. Next one, marked. And see, when you are going from first to the second one, this one is already covered. You don't want to go back. This number when you are comparing, this term when you are comparing, this is not having any other match. So that part is taken care. I mean, if there is a match, you have taken care of it. You don't have to go back. You always go forward. When you have looked at the third term, you don't have to go back. So your number of terms that you have to deal with or compare, that will keep on reducing. So it will be fast. So you have to just go in a very simplistic approach to get to this. Okay. So this is about adding polynomials. Same thing we'll do when it comes to subtracting polynomials also. But before I move on, is everybody clear here? Is everybody clear? Arya clear? Vasundhara, Vishwa clear? Ananya clear? Do we really want to do subtracting polynomials? We don't need to. It's the same stuff. Okay? I'll give you guys some problems to solve as an assignment and see if you guys are able to sail through this easily or you guys are facing any difficulty. Okay? So addition, subtraction are the same stuff. We'll just take one problem with multiplication of polynomial and see how comfortable you guys are. If I have one polynomial x squared plus 2xy and second polynomial is x minus 2y squared, can you multiply these two polynomials real quick? I have one polynomial x squared plus 2xy and I have to multiply that with the second polynomial. It might be something little tricky. I'll give you guys a minute to, okay, let's do it this way. I will not ask you guys to solve it because that might take some time. We are already at the top of the hour for the class. So, can somebody tell me the story? How will you do it actually?
You just foil it. You just foil it like times every.
Foil it? Okay. How will you do that?
I do the box method.
Oh, like the box? Okay. Okay. Vishwa, Abhi, do you guys know how to multiply one polynomial with another polynomial? Yes, Sanvita.
Like you would do distribution.
Yes. So this is called distribution method. So I am seeing something interesting that Sana is doing. She put this like a box. Okay. So that is another way of doing it. Okay. So here what Sanvita said or what Sid was saying, if I have x minus y squared, whatever it was, okay. What you have to do is, what it means, let's look at one basic concept. If I am trying to multiply 15 by 3, okay, I can say 15 as 10 plus 5 into 3. Imagine this as somebody like me who only knows table till 10 and you are asking me to multiply 15 by 3. Okay, so I'll say, okay, I know only table till 10. What I'll do is I'll break 15 into 10 plus 5 and then multiply 3 with 10 and then multiply 3 with 5 and add them together. Okay, so this is where you're distributing it. This whole thing you're distributing it becomes 3 into 10 plus 3 into 5. Same concept is applied here also. Let's say when you have to multiply this whole thing with this thing, what it means is you will pick this guy, multiply with the whole thing. You will say, okay, x squared times x minus y squared. and then plus 2xy times x minus y square. Okay, this is one option you have. You'll say, no, I don't like this one. This guy is not my favorite. I like this guy more. Okay, fine, no problem. You'll say x times this whole thing minus y square times the whole thing. So this can become this, or you can say x times x square plus 2xy minus y square times x square plus 2xy. In both the case, what did you do? You fixed one thing. You said here you fixed this guy and then multiply this number with whole thing, then this term with the whole thing. This was the first approach. Or you say, okay, no, I'll fix this guy, multiply these terms. Basically, you are distributing it against the term that you have in the polynomial. Okay. So that is about. Yes, Ariya.
So I have to go soon, but
Yep.
how longer of classes?
30 more seconds. We almost done.
Oh, okay.
Yeah. So basically, this is distributive property, and this concept is something. Even if this looks kiddish, childish, or easy, this will be one of the most important concept that you all will use for rest of your journey with algebra. So adding, subtracting, multiplying and dividing polynomials, we have only talked about adding, subtracting and multiplying. Dividing is something that we have not done yet, and we'll do that in the coming classes. But these three basic operations with polynomial manipulations are going to be a backbone for us to deal with algebra hereafter. So what I'll do is, I will give you guys some assignment on this one, just to see how you are able to break it down and solve it. And now if you get stuck, obviously video is always there for you guys only. So watch it, try doing it, and if you still get stuck, we will try decoding that in the next class. Alright? So next class we'll talk about polynomial division, and then we'll talk about how do we relate that with dealing of quadratic equations or polynomial expressions with higher power, and then how do we deal with them. Okay? With that being said, I'll let you guys go. Enjoy the rest of your evening, and I'll come back to haunt you.